We're in filming mode. Yes. Okay, good. Let me go stand over here so I can breathe. All right, so this is the last new idea in this unit, and I will tell you that for some of you, this next 15 minutes might be the most painful part of the entire unit. But if you stay with me, you're going to see beautiful stuff. You're going to understand why I love being a mathematician. There is some amazing, amazing stuff that is going to pop out of this. If all goes well, 15 minutes from now, you will all be able to look at this problem, and I kid you not, 5 seconds or less. 5 seconds or less to solve the problem. Have faith. Have a quick strategy conversation though right now. When you see this problem, what are all the things going through your head? What's all the calculus you would have to do? Have that conversation.
I mean, love it. I mean, I think you would start with the, you call it the squiggle, and now I have, like, I always have to
plug in those values for you.
I wouldn't do that. I would find that last.
No, I'm talking about general.
I don't
Because the derivative of the next one. So the
You
exponent
bring that
added.
down, and then
Bring
you
it down,
and you try.
All right.
subtract. So bring it down.
So here are some of the things that I've heard. I've heard some folks, let's close out the conversation. I've heard some folks say, hey, in order for me to do this, I have to do integration by substitution. I'll tell you, integration by substitution is nothing to do with this problem. There's no need for integration by substitution. I've heard some folks that said, I'm going to have to find an antiderivative. Other folks said, I'm going to have to evaluate, right? Because we've got those limits of integration. Some people even said they know they're going to have to find a derivative. All these things are true. I want to look at this with fresh eyes. What am I asking? But if without this, this is a definite integral, right? And the moves to evaluate a definite integral, first move?
Find the baby.
Not find the baby. No. You're stuck in integration by substitution mode. Find the antiderivative. If you can do it on sight, great, do it by sight, because maybe you recognize the pieces. Or maybe there's some algebra. Or maybe there's integration by substitution. There's all those things that are happening. Once you find the antiderivative, then evaluate. And then for whatever reason, there's this d dx happening here at the end, then you take the derivative. This is a long problem. Have faith. So, first thing, we're going to find the antiderivative. Okay. So find that antiderivative. I'm going to use the colors, use my best notation and my best handwriting here. You're capturing all that. Feel free to use the colors. It's worth it. E to the t over 3 is one that I hope you know on sight how to find the antiderivative of. How many of you guys feel like you know it on sight? You just know it. 1, 2, 3, 4, 5. Okay, for folks that aren't seeing it on sight, what advice would we give them? E to the t over 3. What's maybe a better way to look at this problem? That would be a little bit easier. Marvin, what would you do?
Break it into 2 pieces since you're adding.
What do you? Okay, so we've got 2 different pieces here, but specifically this e to the t over 3. There's another way to think of t over 3.
1 over 3 times t.
Okay, isn't this the same as 1 over 3 times t? And now, on the side, there once was a time where you guys were struggling to memorize this, but you know that the antiderivative of e to the kx with respect to x, everyone's going to tell me is?
1 over k.
1 over k.
Times e to the k.
Times e to the kx plus Charlie, right? That is in this form, right? Except k here is 1 over 3. So the antiderivative using this form is going to be still e to the 1/3 t, and then 1 divided by 1/3. And probably most of you guys are going to go straight to 3. Okay, now I need to know, what about this sine of pi t over 2? Well, let's do a little bit of legal rewriting over here as well. Pi over 2t. Okay, antiderivative of sine kx dx. You guys know that one.
Negative. No, 1 over k.
Care-
Negative
antiderivative of
1
sine
over
is
k.
negative 1 over k.
Cosine.
Cosine
kx.
kx plus Charlie. So the antiderivative here is negative 1 over pi over 2 cosine pi over 2 t. All that was to find the antiderivative. Hey, Mr. Newcomer, how are you doing?
Great, how are you?
Okay, not the final answer. Because? What's your next move?
Oh, the.
What are you gonna do, Edgar?
The definite, not the definite, what they're called?
What are we
Yeah,
gonna do?
evaluate.
Right, you've got to evaluate. We've got to evaluate from 2 to x, and then even when you're done with that, you've got to go find the derivative. And remember, we are in the pain part. The beauty is going to come in like 3 or 4 minutes, so Mr. Newcomer, don't leave till we get to the beauty part. So we got over here. I've got to evaluate. Great, so I'm just going to plug in. We can do that nice and easy. 1 divided by 1/3, let me call that 3. E to the 1/3 x minus 1 divided by pi over 2. That's really 2 over pi. Cosine pi over 2x. Everybody okay with just the plug-in part? Okay. Minus, plug in the 2. 3 e to the 1/3 times 2 minus 2 over pi cosine pi over 2 t. This is deliberately ugly, but the beauty is coming. Yes, ma'am.
The T be a 2?
Oh, thank you for making me a better math teacher.
And then it should
So
be
pi over 2 times 2. Good catch. Good catch. We got here by doing the antiderivative. This next part over here was just evaluate. We're almost done. Jonathan, what's the last move? You've got to go find the derivative. Okay? Let's take a minute. Go find the derivative.
Oh god.
I know. Have faith. Have faith. I need to find the derivative of 3 e to the 1/3 x. Gotta go find the derivative there. Derivative 3 e to the 1/3 x. The beauty is coming. The epiphany is almost here.
What's the derivative? Oh,
Derivative of 3 e to the 1/3 x. 3 e to the 1/3 x times 1/3 because of that chain rule. Minus 2 over pi is a constant. I'm just going to ignore it. Derivative of cosine, negative sine, pi over 2x times pi over 2. That's just the derivative of this part over here. Minus
oh,
derivative of 3 e to the 1/3 times 2. Don't fall for it. Don't fall for it.
3.
The 20 of you are way too smart. Don't fall for it.
3 e to
One more time. What's a constant? All the stuff. All the stuff is a constant, right? There's no variables in here. So the derivative is
0.
0 minus derivative over here.
Oh, it's sine.
Oh gosh. Oh gosh.
The whole thing is.
No.
All this stuff, Jose, what do you know about it?
Sine of
They're all constants, and the derivative of a constant is? 0. Okay, you're like, hey, no, we're not there yet. Stay with me. Let's clean it up a little bit more. So my little note over here is just going to be clean it up.
I have a question.
Oh, hold on. We're going to get there. I'll take your question in just a bit. 3 e to the 1/3 x times 1/3. 3 e to the 1/3 x times 1/3 is e to the 1/3 x. Negative 2 over pi times the negative over here is positive 2 over pi times pi over 2
1.
is 1. God, that just makes me want to smile. Why? Look at this problem. I know we just went deep. You just put all your calculus skills together. Mariah, I think you're seeing it. What are you seeing, Mariah? It's God, you're not smiling. You're not smiling. See, when I say it, I smile. You see this and what? This is the same thing as what we started with. Not quite.
The variables change.
David, what's different?
The variable changed from T to X.
The variable has changed from t to x. We have done all this beautiful work. We have done all the things. All the things is what Caroline tells me. We took the derivative of the integral of a function from a constant to a variable, and what did we get? The same function back. Same function with a new variable. If that doesn't make the 20 of you smile, I don't know what ever would. This is the second fundamental theorem of calculus. The second fundamental theorem of calculus, for those of you that are like, but wait, where's the first one? The second fundamental theorem of calculus says this. The derivative of the integral of a function from a constant to a variable. The next time you are asked to find the derivative of the integral of a function from a constant to a variable, your final answer is going to be
Change the thing.
The function
the original function with a different variable. That is ultimately the second fundamental theorem of calculus, Anthony. So you start with, this is your original function, the a, constant, the x, your new variable. Your answer, original function with a new variable. This is the second fundamental theorem of calculus, one of my all-time favorites. It's on the AP exam. I'm so glad you stopped by.
That was magical.
It really was magical. It brings a tear to the eye. Tear to the eye. That's the second fundamental theorem of calculus. The second fundamental theorem of calculus is here to make your life better, just like I am. But you have to have all the right pieces. What are all the right pieces? Tell somebody near you what are all the right pieces that you have to use this.
the constant, the variable. Like it's just to
That's time for 1/3. Because it's the same thing as time. The derivative of this function.
what skill?
To find the derivative of
Yep.
t, you have to
Yeah,
What's the point?
that stays the same, but you must
Just
go
to
back
geek
and
out
check the
together.
derivative with the explanation.
Really? Okay, so before you start using your new tool in the wrong way, the second fundamental theorem of calculus, all the pieces, derivative, integral, function, from a constant to a variable. This is the second fundamental theorem of calculus. We will get to what's the point, I promise. What are the other questions that are out there? I bet there are questions that are out there. One.
So how would you show first before?
That's the beautiful thing! That's the beautiful thing! You don't. You just eat, all you need to know. So Juan, here's the thing, you run through the checklist. What are all the things I need to have? The derivative of the integral of a function from a constant to a variable. If that's the case, boom, there's your answer. Done. That's all. That's all. Other questions that are out there? We're going to get to what's the point. Okay, let's try another one. I want to rock your world a little bit more. Okay, let's do one more beautiful question. Problem number 2. Ooh, let's really clean off the space here. I feel so sad for Eunice and Rambir.
They'll be fine.
They'll be fine? Okay. All right, so number 2, we're doing an integral. Was it 5 to x squared plus 1?
But we know what the
but this one has x plus one.
Okay. And this is not a place where you get to use the second fundamental theorem of calculus. Because
It's x squared plus one.
that upper limit of integration is not a variable, it's something more complicated. So let's run through the process. Let's do all the things. All the things. Where do we start?
And the antiderivative.
Find the antiderivative. So go get me an antiderivative.
Not sure. No.
Let's see, antiderivative. 1 over the square root of t. Let's see, I can do a little side work here. 1 over the square root of t, that's really the same thing as what, t to the negative a half dt? Abraham, how does that work? What's the antiderivative of t to the negative a half?
Or like 2.
Think about antiderivative. Antiderivative. Power up. Right, so it'll be 2t to the half. Is everybody okay with the 2t to the half? Even now at like 25 years old here, I add 1 to the power first. Don't laugh at that. Add 1 to the power first, then I divide by the number. So now I've got 2t to the 1/2, and I need to evaluate from 5 to x squared plus 1, and I need to find the derivative. David, what's your next move here? Let the notation, this beautiful notation, be your guide. Evaluate. Perfect. What did you really tell me to do, David?
Plug in.
Plug in. So everywhere there's a t, plug in this x squared plus 1. 2 times x squared plus 1 to the half minus 2 times 5 to the half. Not your final answer. No one's going to fall for it. This is not the final answer because
Find the derivative.
I still need to find that derivative. So go find the derivative. Have faith. Find the derivative. So I've got 2 times stuff to the half. So 2 times, bring that power down. Stuff to the 1 less power. Times the derivative of stuff minus derivative of 2 times 5 to the half. Derivative of 2 times 5 to the half is
0.
0, right? Because all this stuff is a constant. Okay. All right, maybe we do a little like clean it up. All right, clean it up. 2 times a half, 1. X squared plus 1 to the negative a half is 1 over the square root of x squared plus 1 times 2x. Ta-da! What happened here? Talk to somebody near you. What just happened? What's the fast way to get there? What's the 5-second way to get there? No. Second time you've said that, second time, no. You cannot do this stuff on the calculator. How would you get there in 5 seconds or less? Look at where you started. Look at where you're ending. This really should be a 5-second conversation. Right? Instead of 1 over the square root of t, 1 over the square root of x squared plus 1. Why is that 2x there? It's the derivative of the baby. So this is called the extended second fundamental theorem of calculus. If you have the derivative of the integral of a function, tell me about these limits. Uh-oh.
Constant on the bottom.
Constant on the bottom. Not a variable anymore.
Not a variable. A function.
Just some other function. I'm going to call it g of x. So let's label all the pieces here. The f of t is the old, or your original function. Okay, original function. The a is a constant. The g of x is a new function. That final answer. Derivative of the integral of a function from a constant to a new function. Look what happened over here. It's f of
G of
right
times
times
G prime.
g prime. So let's label those pieces. F is the original function. G,
Second.
new function, right, or the second one. And this guy here
Derivative.
is the derivative of the new function. Now, I heard somebody whisper it. I bet that looks familiar. Nope. This is not the chain rule. This is not your mama. Not the chain rule. Why not the chain rule? Raise your hand when you see it. Why is this not the chain rule? I know why people are thinking chain rule though. This is not the chain rule. David, why not the chain rule?
Because in the chain rule, you would have the mama be the derivative.
We'd be taking the derivative of the mama, leaving her baby alone, times the derivative. This is not your chain rule. Not the chain rule. Okay. Everybody mostly okay?
Hi.
Okay. These should be super fast questions. You guys are going to show me how super fast.
Wow.
Okay. I'm going to put 3 minutes on the clock. Hold on. Slow it down. Slow it down, Jonathan. Slow it down. He's already like, I'm off to the races here. I'm going to show off. Okay. There are 3 multiple choice questions on page 3. I'm going to put 3 minutes on the clock. When you think you are done with all 3, call me on over. I'll high five you and tell you what to do. But you only get 3 minutes. Ready, set, go.
Just 1, 2, 3.
That's probably 1, 2, and 3. 3 minutes. Cheaters! Cheaters! That's how it works in that group.
F of G of X. This is G of X.
See, you infected the good kids now. You're going solo. That's why it says independent practice. When you think you've got all 3, you're going to call me over and I'll high five you. And I'll tell you 1 out of 3.
1 out of 3.
1 out of 3. 1 out of 3. 2 out of 3. 2 out of 3. Nope. This is not like The Price is Right where we start switching the signs. 1 out of 3. Oh, you guys helped me get close to my 10,000 step goal. 1 out of 3. 1 out of 3. Oh, it's like I gave a monkey a power saw. 1. I'm not even sure what I'm looking at. DD, how would I know that? Those are the tiniest circles. And oh my God, that's not even a circle. 1 out of 3. 1 out of 3. Wait, what are you circling down here? 1 out of 3.
What is this witchcraft?
1 out of 3. You guys don't listen. Now I have proof. I have data.
Wait, Mr.
No, I'm going to my 10,000 step goal.
What you mean?
I'm just making stuff up now. 1 out of 3.
I mean, we're gonna work my process.
Now you're at 2 out of 3, but I don't think you know why you're at 2 out of 3. Time's up. Here's the one that everybody got right.
Number 1.
Number 1. Number 1, second fundamental theorem of calculus, cuz what are all the pieces?
The derivative,
The derivative
the variable,
of an integral
and then
of a function from a constant to a variable. The fundamental theorem of calculus says cosine 2 pi x d. Most popular wrong answer, the most popular thing that I saw for part number 2, most popular wrong answer is A. Jasmine, why is it not A?
Because it doesn't even ask for the derivative.
Hello? Not asking for the derivative. This is why it was like giving a monkey a power saw, just waving it in the air.
So what was it? Negative
Not your second fundamental theorem of calculus. So do the only thing that you're left with. Find the antiderivative. And the antiderivative is
Negative cosine of x.
negative cosine of t from 0 to x. Now plug in. Negative cosine x minus negative cosine 0. So negative cosine of x plus cosine of 0, and cosine of 0?
That's a lot of math.
I know, I'm tricky. That's E. Number 3, most popular wrong answer
E.
is E. The extended, this is the extended version, derivative, integral, function, constant, new function. The extended version says make this the square root of 1 plus x squared squared. X squared squared. Now multiply by the derivative, which is 2x. X squared squared, x to the 4th, so the right answer is going to be D. Okay. I will tell you before anybody gets really upset and you're like, but I wanted to get all 3 right. That's the kind of girl I am. I have never in 3 years had any student get all 3 of these right in those first 3 minutes. The key with the second fundamental theorem of calculus, you have to stop and check all the parts. It's got to have all the things. Tell somebody near you, what are all the things? Make sure they know all the parts to check. What are all the things?
Integration.
And the derivative.
The definite integral.
Okay, I need to see the derivative of the integral, of the function, from a constant to a variable. These are all the things. All right, friends, here we go. New round of practice. Let's see how we can do it this one. 3 problems. These are harder. These are more recent. This is more consistent with what you're going to see on Monday's quiz and Thursday's test. When you are ready to check your answers for the first 2 with me, let me know. I'll come on over and let you know how you're doing. Take your time, check the parts, make sure you've got all the things going. Minutes till cookie time. These you can definitely work with a partner, Jose. Okay.
For one. The derivative of the square root is 1 over 2 square root of x. The square root is 1 over 2 square root of
Nice job. Nice job. Nice job. Nice. This one's got all the small derivative function.
I did.
All the
What are, I've never heard this one.
It said, I thought you were talking about the spinners you made.
Yeah, I
I was like, bro, everybody made those. Nobody manufactured it. I was like, you're
Hey, keep going. Number 2's trickier.
Oh, you're supposed to subtract. How did we do it last time?
Okay, from what I can see, everybody and their mama pick B for number 1. It is definitely second fundamental theorem of calculus. Nope. Number 2's much harder. Keep going. Anthony, you're all stretched out. You're ready. Get back in there.
Number 2 is the second fundamental theorem of calculus. You just because you do, but I can't just.
You're still on G, right?
It's just 2, right?
Why are you glaring at me like I'm the prison warden? Teamwork prisoner
So first you plug it in, right? You plug in 2x to the function. Then you find the derivative of whatever's inside, right?
Wouldn't it be like this?
The original derivative.
This already gives us 1g,
Oh, wouldn't it be the same thing as this? Should we have
David Moore.
this? So then it'll be f of g of x.
I don't know what you're saying.
Wait, but we only know it when
It's the top of this thing. Like now, it's constant, right?
It just has to be a constant.
What's the original constant?
The way I thought about it first is to get the derivative, then it's
I don't know.
the 2 of the derivative.
F of G. It is F of G of X times the derivative of G.
The problem is what is the derivative?
Yeah,
I can't second guess the derivative.
G.
Squared? Because you can't 2x with t, right? You get 2x squared.
you don't find the derivative. You don't find it.
Basically, finding the derivative.
Yeah, I'm not finding a derivative, I'm literally plugging it in. I just plugged in 2x to this. This is the function, the original function.
Oh, okay.
But then I don't know what the derivative is. It's 4x.
Squared minus 2x. Wait, Mariah, wait. It's not. Wait, I got Four squared.
Is anybody in need of a little bit of a nudge on number 2? I'm not going to tell you there, just a nudge. Just a nudge.
It's G.
Oh, hold on.
I worked it out.
Oh, my God, I'm so happy for you. We're going to hug it out in just a minute. Okay. Just a nudge. Second fundamental theorem of calculus, sir?
Yeah.
Juan, why not?
Because it doesn't have the derivative on it.
There's no derivative here. Don't use the second fundamental theorem of calculus. But what am I really asking for, Abraham? How do you know that? How do you know?
A derivative of
But what
F
am I asking you for? I want f prime of 2.
Yes.
So this is a 2-step process. To find f prime of 2, first find f prime of x. First find f prime of x. Once you know what f prime of x is, then you plug in 2. So f prime of x means I need you to find the derivative. Find the derivative of this integral. Second fundamental theorem of calculus,
Yeah.
right? Okay, so Edgar, you probably did something like that. And then
2.
Times 2. Because that's the extended version, right? You plug this guy in, and then you multiply by the 2. So f prime of 2 is going to be square root 4 squared minus 4 times 2, which if you clean that up is the square root of 12 times 2, or 2 square root of 12. So, G. Besides Edgar, how many of you honestly had G? Jennifer had G, Edgar has G. Okay. All right, we get 7 minutes to tackle number 3. Jonathan. The reason that 2 is there is that this is the derivative of the 2x. That's what the extended version says. All right, number 3. Let f be this function over here. In which of the following intervals is the graph of f concave down? I picked this question because it is a great review of all the things that are coming up on this trimester exam. Concave down. That means something to us in the calculus world. Concave down. Jennifer Ortega, what does that mean to us? I'll take anything that you know about concave down. If your graph is concave down on a particular interval, the tangent lines give you an overestimate. That's all that you said when you said the word it. Yes. If your graph is concave down, the tangent line gives you an overestimate. What else though? Concave down. What do we know about concave down? Jennifer knows stuff about concave down. Jonathan knows stuff about concave down. But nobody in the middle knows anything about concave down. You guys all draw in the air for me, concave down? Okay, good. People know stuff about concave down. Everybody's like, that. And we used to do that. Concave down. There's 2 ways to show concave down. 2 ways. 2 ways. 2 ways. Concave down. Oh, so awkward. I'm not telling. I'll just let you guys dangle. 2 ways. One involves the first derivative, one involves the second derivative. Anthony, tell me about concave down. F prime is what again? Keep guessing. F prime is decreasing. Anthony, F double prime is? Now is where we say negative. F double prime is negative. So look at what they gave you. For number 3, they're saying that f of x is this integral from 0 to x. Oh gosh, what is that? I crossed it out. Is that 2t cubed minus 15t squared plus 36t dt? Well, get me f prime. I bet most of you guys know exactly what f prime is without even thinking about this. F is the integral of that function from 0 to x. F prime of x?
Change the variable of this,
Just
the original function.
change the variable. Do not do anything else. Change the variable. This is f prime. I wouldn't expect most of you to know exactly what this looks like. Maybe your polynomial things are happening and you're like, one end goes down, one end goes up, all those things are happening. But I need to know exactly where decreasing and increasing is happening. There's a way that we used to attack problems like this. Jennifer, what would you do? Oh, you're killing me. What's your question?
Wait, okay, so for the first one, you added the d over dx.
I added the ddx because we started off with f and we needed to find f prime. That's what the ddx means, go take the derivative. I could have chosen to write that over here, but I thought this was an easier one and we'd be okay. Okay? The thing that I've heard whispered on the air is the number line test. The number line test works really, really well when you're looking at like where things are positive or negative. So you want to do your number line test. For those of you that are comfortable with the number line test, finish it off on your own. For those of you that need a little bit of a nudge here, stay with me. Number line test. The second derivative is going to be negative, so Go give me the second derivative. F double prime. What is that second derivative? 6x squared
minus 30x
minus 30x
plus 36.
plus 36. The number line test goes something like this. Find the roots. Right, find the roots. Set this bad boy equal to 0. Find those roots using your good algebra skills. I don't know that I'd factor out an x. Okay, maybe I can factor out a 6 to get to x squared minus 5x plus 6. Now x squared minus 5x plus 6, that needs more 11. That needs some factoring. Right, maybe you do the x box or however it is that you want to approach it. I know some of you guys are just able to look at it and you know how it factors. Right, it's going to be an x minus 3 and x minus 2. The reason for the factoring is because this tells you the roots, this tells you the solutions. So your roots are x equals 3 and x equals 2. Those aren't your answers. Right, you need to, the number line test, you need to make a number line here. So you need to do a number line for f double prime. Here's x equals 2. Here's x equals 3, equal to 0, equal to 0. An option here, you pick a number to the left of 2. Like 1, 0, whatever you want, it's fine by me. Plug it back into this guy over here, if you want to. How about this guy here? How about this guy here? Usually the factored version is going to be the way to go. If I plug in 0, hold on, stay with me for a second. Okay, if my test value is 0, plug in 0, what are we going to get?
36.
Remember, I don't actually care about 36.
Positive.
I care about one thing only.
Whether it's positive or
Positive or negative. Plug in 0. 6, negative, negative, positive. I need a good test value between 2 and 3. 2.5. Plug it in. 6. 2.5 minus 3.
Negative.
All I care about is negative here. Over here.
Positive.
Positive. 6 times negative times positive. Negative. Test value after 3.
4.
3.5, 4, whatever. 6.
Positive.
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 Positive. Final answer?
Positive.
Positive. The question, where is the graph concave down? On this interval from 2 to 3. Just real quick before I let you guys out of here. How many guys knew that's what the number line test was going to look like? That it had to go positive, negative, positive.
Is it because of the 3?
Noemi, you knew it had to go positive, negative, positive. Mariah, you knew it had to go positive, negative, positive. Mariah, how did you know it had to go positive, negative, positive? That's not quite. That's not quite. Marvin, why positive, negative, positive?
Was it because of the x value?
What's this the graph of? It's a parabola. Opening which way? Up. If there's 2 roots, doesn't the graph have to look like that? Right? Above the x-axis, below the x-axis, above the x-axis. All the things, all the tools. Tonight's homework has nothing to do with the second fundamental theorem of calculus.
What was the answer?
The answer was D. Tonight's homework, 8 problems involving integration. Some of them are substitution, some are not. Some of them are definite integrals, some of them are indefinite integrals.